to start off with, if you remember at the beginning of the semester, we started off with kind of the basic stuff from Chem 1. Temperature conversions, density calculations, specific heat, more specific heats.
Conversion, specific heat, and what?
Do it. Temperature conversions, density, specific heat, and specific heat in both calories and joules. Conversion factors like from metric to US and US to metric. Then we go into calculating molarity of solutions. Percent mass. For instance, if I'll give you a formula of something, you'll need to calculate its atomic weight. You'll need to calculate the percentage if I gave you an organic molecule like sugar and I asked you what the percent of hydrogen is in it.
Oh,
Converting from like grams to moles and moles to grams and molecules and all that. Resonance structure. Organic molecules, drawing some of the organic molecules.
Is that the functional group?
Yeah. And you have a list of the functional groups in the back of your books. TJ, I have 2 copies of my book. Y'all can borrow them. They'll be around in the room. Let's see, valence electrons, and using electron dot to figure out the shape of molecules and whether they are polar or nonpolar. Equilibrium constants, calculating pH, calculating half-life reactions, and we'll have nuclear equations on there, balance. In the lab portion, we'll get into empirical and molecular formulas.
Say that again.
Molecular and empirical and molecular formulas. Balancing regular equations. From words or from names, writing the formulas and then balancing those equations. Figuring out solution concentrations from lab information. Reaction rates. That's another specific heat problem. And that's really, I mean, it doesn't sound like a lot, but.
How many problems total?
Let's see, for the lab, for the class part, there will be 15. For the lab portion, it doesn't. Of course, there are multiple steps. Okay, so if I did give you a formula for, So I gave you that formula. How would I figure out the percent hydrogen in that formula? First, you're gonna add up the weight. So we've got carbon, we've got 12 at 12, which is 144. Hydrogen, we've got 22 at 1, which is gonna be 22. And oxygen, we've got 12 at 16, which is gonna be 160, what's that, 192? If I multiplied that right? Add all that up. Is it 82? 160? And then 2 times 16 is 32? 192?
Hold on, you did what again? To get the, do it one more time? I see what a 358 is.
Okay.
And what else did you just do over there on the side?
Over here,
Oh,
I
she was
look-
just calculating the
I was
oxygen.
calculating 12 times 16. You know the shortcut for doing that?
It's not good.
Calculator.
16 times 10 plus
16 times 2.
Mhm.
That's all I did.
I did 12 times 12 plus 12 times 4.
So now, we've got a total of 358 grams. And of that, 22 out of the 358 is the hydrogen, and times 100 will give me my percent hydrogen. If I did 144 over 358 times 100, that would equal percent carbon, percent hydrogen, and then 192 over 358 times 100 would equal my percent oxygen. And all of that should add up to 100. Yeah. Okay. So then if I ask, what else am I ask? Figured this was a while ago, so it's probably the least likely to remember this stuff. Let's see. So if I asked you how many atoms of carbon are in, say I gave you half a gram of sugar, that's what that is. How many carbon atoms are there? So, let's start off with, this is where you go into your multiple ratio and stuff like that. So if I start off with 0.5 grams of sugar, 1 mole of sugar is 358 grams of sugar.
And 1 mole of sugar has 12 moles of carbon.
Okay, 1 mole of sugar has 12 moles of carbon. And then going to atoms, so 1 mole of carbon has 6.022 times 10 to the 23rd atoms. Simple enough? Okay. Okay. Oh, lots of more questions on this test. I said, I'll have some of the questions on this test. Just evil, pure evil. All right, if I gave you and ask you to draw out the structure. What would it be?
Draw the structure.
Draw the
You'll
structure.
have 5 carbons,
Mhm.
and then you have 8 hydrogens coming out of 5 carbons.
Right. Is that enough hydrogens to cover all the carbons? Nope. So that tells us pretty much there's a multiple bond in there somewhere, because every carbon has to have how many bonds? 4. So let's go ahead and do this. There's 6. Now what?
Missing a double bond. Wouldn't it be in between the second carbon? and
Doesn't really, we don't really know where it would be, just have to have one. So say I put my extra 2 hydrogens there, so I'm gonna have to have a triple bond there.
The arc is two,
Double bonds.
Well, yeah, I guess it would, hold on. Would it? So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2,
And then just
3,
stick
so
another
we have
one
an
there.
H, there we go. That works, that too.
But you could do it.
Either way. And I might say this structure as an alkene, which means it would have double bonds, or is it an alkyne, which means it had triple bond. What if it were
How would you draw it? There'll be 3 carbons.
Okay.
And since it's alcohol, it'll have an OH at the end.
Good.
And then I'm lost.
Well, there's 1, so I need 7 more hydrogens. 1, 2, 3, 4, 5, 6, 7. What would its name be?
So that's gonna be ethyl.
Purple.
Propyl.
3 is purple. Pro.
Propanol.
For single bonds. No, for an alcohol.
So when the A changes to the E, that means it's a double bond. Okay.
And when it changes to a Y, it's a triple bond.
Okay.
But we reduce the number of hydrogens every time. Okay. What is molarity? It's the unit.
Moles per liter.
Moles per liter. Okay. So if I gave you what would, and I asked you for resonance structures. So we'd have this. And what does a resonance structure mean?
It means that there's 3 ways to do it.
3 ways, in this case, 3 ways it can be written with a double bond here, or we could do this, or we could do this. Basically what it means.
So resonance structures mean there's 3 ways you can write it?
Not necessarily 3, there are multiple ways you can write it
Okay.
with a double bond in a different place each time. There's a hair in it earlier. Making sure I got it out. I got a dog hair. What's its name?
Pro.
Penta, no, what is two? No,
Pentene.
In this case, we can name the whole chain. It's not an ester, which is where you name the two different parts of the chain.
Penta,
Be pentene.
pentene.
It's pentene, but it's 2-pentene. Remember, we have to use the number to tell where the bond is, the double bond is.
What?
You use this to indicate where the double bond, what carbon the double bond's from, and you start with the shorter end. Now, what will be its condensed molecular structure?
It would be, C.
CH3, CH, oh, wow. 10.
That's its condensed molecular structure.
So you don't have to, when you do the condensed molecular section, you don't have to worry about where the double bond is.
But if I gave you what would that look like?
It would be C.
4
C,
C's.
C.
4 carbons.
That'd be a triple bond.
So
The
it'd be
triple
a
bond on the third
Triple bond
carbon.
on the third.
And then OH attached to the end.
Actually, OH would be,
And then 1, 2, 3, and 2. No, just, yeah.
okay. You guys remember specific heat formula? Okay, it is calories equals the specific heat times your mass times your delta T. Guess we had somewhere to go? Do what?
He reads class all the time.
He brought his biology notebook to chemistry notebook, and he's going to give it out.
When you're in wellness, he's like, I can't take this anymore, and he gets up and leaves. Like, an hour later, he comes back with.
Alright, so if I said I had a piece of aluminum that weighed 10 grams, and aluminum has a specific heat of 0.22 calories, grams, degree C, and I put it in water, and it changed from, let's say, 25 degrees C to 70 degrees C. How many calories did that take? So we just simply say calories equals 0.22 calorie gram degree C times our mass, which is 10 grams, times our delta T, which is 45. So here our grams cancel out, here our temperature C cancels out. We're left with nothing but calories, which is what we're looking for, so it's 2.2 times 45, which is gonna be 850.
Should be 99.
99?
Mm-hmm.
Thank you.
Yeah.
So, 99 calories?
Mm-hmm.
Not much.
Are those gonna be like 2-part questions where before we had to solve for calories and then put it back into a second equation to get the specific heat or something.
That's if we don't know all the parts. Like for instance, if I just knew the temperature change of the water and the mass of the water and then the mass of the metal and the how do I rephrase it? That's where you use like a calorimeter.
Yeah.
And you have to
that's what
calculate
I
the
did
water
with
first, because the heat loss to the water is the heat, or the heat gained by the water is the same as the heat lost by the metal. So you're gonna, you're missing two variables for the metal. So,
Are there ones like that?
there are ones that are multiple parts, yes.
Yeah. Like I think, like I found my old labs from Chem 1, specific heat, how to set them up.
No, you just use that formula and plug in what you know. You do the water first, and then the metal. How do you write an equilibrium constant expression?
Products over heat.
Products over reactants, yep.
Natural what?
Products over reactants.
For
You've got-
equilibrium constant.
For instance, if you've got, let's do,
KEC.
thin air. Okay, so what's that gonna make first?
Sodium sulfate.
Hydrogen.
Okay. So then we've got to balance that equation. So we're gonna have 2 over here. And 2 there. 2 sodium, 2 sodium, 2 chlorine, 2 chlorine, 2 hydrogen, 2 hydrogen, 1 sulfur, 1 sulfur, 4 oxygen, 4 oxygen. Okay, so we're balanced. So if we write the equilibrium constant, you either see it as Kc or Keq. It's gonna be the product, concentration of this, times this, over this, plus, sometimes. And your coefficients are used as powers. Yeah, that's really everything that's on here. Give you a example of a problem, ask you to draw this condensed structure formula for the material, then to write a balanced chemical equation for the reaction and calculate the energy. Calculate moles. Don't know how to do that. I can't dance to that. Alright. That's really about it so far for this. What do you think? Is there anything that you're not feeling confident about?
Oxidation reduction.
Are those gonna, is there any on the final?
There will be one, but it will not be the hard
Like about what was on our
Yeah.
exam? Okay.
It won't be the hard, like, one with the, like E, it won't
Did you
be
ever
that.
figure out that one?
That's why, I guess before you walked in, I have looked it up online, I mean, Ms. Hilding and I worked on it for a while, and I just got pissed.
Yeah.
And I looked it up online, and I could find where it was balanced,
Yeah.
but could not find how they got there, and could not figure out how they got there.
Just the answer.
So I'm just throwing that question out. That was
Okay.
not a
Which
good
one?
E on, the worksheet.
The oxidation reduction.
The oxidation reduction worksheet.
Part 4, number,
Yeah,
letter
4E.
E.
No, I don't know, I just find with these ones from myself. Can't get my
Did you do
stuff.
it or attempt it?
What's your schedule
Katrina?
today?
Huh?
Did you
Today?
attempt that one?
After this class, I will
Are
be
you on the
in
worksheet?
my office.
Till what
Oh.
time?
I have training at 1, from 1 to 1:30.
You did it in class.
I've got actually a seminar I'm supposed to be at right now.
Do you ever drop work? My book, I got, so I'm at my class, so I already returned all my homework. I think we got oxidation left or whatever.
Okay.
So I gotta turn that in today.
Okay, I'll be in my office till 7,
Okay.
so anytime from 2 to 7.
So you from 8 to 7 every day?
Hmm?
You here from 9 to 7 every day?
Pretty much. Except on Wednesdays when I go do